Hi, all. So today, this is the continuation of the lecture number 3 for the environmental 1 and 2. We were reading the atmosphere. In previous lecture number 2, we read regarding the atmosphere that what is atmosphere. Actually, atmosphere is the layer of gases like nitrogen, oxygen, hydrogen. It extended up to 500 kilometers above the surface of Earth. Then we have hydrosphere. It includes all the surface and groundwater resources such as oceans, seas, rivers, streams, lakes, reservoirs, dams, glaciers, and groundwaters. And other we have sources of groundwater will be discussed in hydrology. So here we have only the type of hydrosphere or type of waters. Then we have an introduction. We are going to introduce the water formally. Slowly and gradually, we will read about the details of water. Now, everybody knows that water is a combination of two molecules of hydrogen and one molecule of oxygen. So, formula for water is H2O. Water is a chemical compound H2O and is extremely useful to human and providing him the luxuries and comfort and fulfills his or her basic needs of life such as bathing, cleaning, cooking, etc. Every one of us knows how important and precious the water is. No life can exist without water, so water is an essential for life as air. It has been estimated that two-thirds, means around 70% of human body is constituted of water. Water is absolutely essential not only for survival of human beings, but also for animals, plants, and all other living creatures or beings in the atmosphere, in the atmosphere or world everywhere. Here we have a detail that why we have water supply schemes, why it is a key requirement for the public health or human. Water supply schemes are essential for public health because they ensure that communities receive a safe, reliable, and sufficient supply of clean water for drinking, cooking, bathing, and sanitation purposes. When people have access to treated and protected water, the risk of waterborne disease such as diarrhea, cholera, typhoid, hepatitis A, and including all hepatitis and dysentery is greatly reduced. In many areas, especially where people depend on unsafe sources like contaminated wells, rivers, ponds, or tankers, water of unknown quality, harmful bacteria, viruses, and parasites can easily spread through daily water use. A properly designed water supply scheme include safe water extraction, treatment such as filtration and disinfection, storage and distribution, which helps prevent contamination at every stage. This directly improves our overall community health, reduce hospital visits, and lower child mortality rates, and children are often the most vulnerable to unsafe drinking water. In addition to preventing disease, water supply schemes support better hygiene and sanitation practices, which are fundamental for maintaining public health. Why I'm reading and detailing too much? Because this course is designed for the students. They can easily they can take lecture from this. So we have prepared or designed this course for the examination part of point of view, as well as when we will have a lecture or problems, means you can easily attempt your examination for environmental part 1 and 2. So we were here Without adequate water, people cannot wash hands properly, clean utensils, bath regularly, or keep their living environment clean. This leads to the spread of infections and skin disease, especially in crowded settlements. A reliable water supply also strengthens systems because toilets, sewerage network, and wastewater management require water to function properly. Where water is scarce, communities may practice open defecation or use unhygienic alternatives, increasing the risk of environmental contamination and disease outbreaks. Therefore, water supply schemes not only provide drinking water but also enable healthier lifestyles and cleaner surroundings. This continuation that water supply schemes contribute to social and economical well-being, which indirectly supports public health. When safe water is available near homes, people, especially women and children, do not have to travel long distance to collect water, reducing physical stress, injuries, and time loss. This extra time can be used for education, work, and child care, improving family welfare and community development. Business, schools, and healthcare facilities also depend on a stable water supply to operate safely and efficiently. Hospitals need clean water for sterilization, clean patient care, and infection control. Schools need water for toilets and hand washing, which reduce absenteeism caused by illness. In short, water supply schemes are a foundation of public health because they protect water, they protect people from disease, improve hygiene, support sanitation, and enhance quality of life by ensuring a continuous supply of safe and clean water for everyone. Now, what water supply scheme include? A water supply scheme includes the following main steps. Number first is collection, number next is conveyance, number next is treatment, and finally the distribution of water. In earlier times, people lived in small and separate communities. Their water needs were limited mainly for drinking, cooking, and bathing. Each family used to collect water on its own from nearby surface sources such as rivers, lakes, and ponds. Later, as the population increased, towns and cities expanded and people's living standards improved. Trade and industries also developed. Because of this, water demand increased a lot. Small local water sources were no longer enough, so bigger water resources became necessary. In many cases, large water sources are located far away from the town. Also, the water from these sources may not be safe for drinking. Therefore, a water supply scheme becomes very important to collect water, carry it to a town or city, treat it properly, and distribute it to the public. For every town or city, an administrative body such as municipality or corporation is responsible for public health and for providing safe, potable drinking water after after its proper treatment. Nowadays, water is needed for many purposes such as drinking and cooking, bathing and washing clothes and utensils, washing vehicles, gardening, swimming pools, fountains, firefighting, and trades and industries. In some places, water is taken from deep tube wells using a turbine pump and it's supplied directly to consumers without treatment. However, even in that case, a water supply scheme is still necessary to create a proper distribution network to every household. Here we have importance of drinking water and its impacts on human health. You can see we have a diagram of drinking water because in all over the world, water is essential part of our life. So water should be purified one. Death of 5 million children in the developing countries every year is caused by impure water. Here we have disease caused by the impure water. Mainly diarrhea and cholera are the leading waterborne disease. If lack of drinking water, then are we have means these are drinking water quality are we have comparison that lack of drinking water and microbiological contamination. If water is contaminated, then these sort of purities it may contain harmful salts, acids, minerals, organic substances, pathogenic bacteria, radioactive substances, dissolved gases. Hence, the water may possess undesirable color, odor, taste, and ever disease-causing microorganisms. So, this is a diagram of human body which is caused by different sort of bacteria present in the contaminated water. Then we have water pollution. As Earth's population continues to grow, people are putting ever increasing pressure on the planet's water resources. In a sense, our oceans, rivers, and other inland waters are being squeezed by human activities, not so they take up less room, but so their quality is reduced. Poorer water quality means water pollution. What impurities in water if water is called is contaminated water? So pure water can never be available in nature. Even a man-made drop of water prepared in a laboratory by lighting the hydrogen and oxygen gases in a test tube may not be perfectly pure because of the water drop so formed will dissolve the gases of the test tube, although a very little bit. Similarly, the rainwater at the instant of its formation contain no impurities, but during the process of formation and fall through the Earth's atmosphere, it may dissolve certain gases, traces of minerals, and other substances. Here we have impurities in water. As the rainwater flows over the surface of Earth, it picks up or dissolved particles up. Why we are discussing here rainwater? Because in many part of the world, many countries, they use rainwater for their drinking. So that's the reason we are discussing here rainwater on the surface of Earth. So rainwater can pick up dissolved particles of soil, garbage, sewage, pesticide, and other human, animals, or chemical waste. It may also pick up and dissolve certain decayed organic materials such as plants and dead animals. Here we have process that how surface water can dissolve impurities. As the surface water seeps into the groundwater reservoir, most of the suspended particles are filtered out, but on the other end, the water dissolves the minerals and salts present in the Earth's layer through which it travels before joining the water table. Here we have important definition of water table. That what is water table? The upper level of an underground surface in which the soil or rocks are permanently saturated with water, or it is an underground boundary between the soil surface and the area where groundwater saturates, space between sediments and cracks in rock. Water pressure and atmospheric pressure are equal at the boundary. Underneath the water table is the saturated zone where water fills all spaces between sediments. Here we have effects of impurities in water. That means if water contains impurities, then what could be the effects due to impurities? Sometimes the impurities which water dissolve or picks up as suspended matter may make it more useful and portable for public uses. and especially for drinking. And sometimes it may render it harmful and unfit. For example, certain minerals such as iron, calcium, magnesium, and fluorine in small quantities may be useful and good for health of the people because the human beings need to certain amount of these elements in their bodies. But when these materials and others are dissolved in large amounts, then in certain combination, the water may become unfit or less useful for municipal, industrial, and other uses. For example, sometimes water may contain toxic or poisonous substances such as arsenic or barium, cadmium, chromium, cyanide, lead, selenium, silver, and copper, which may be very harmful to public health even if present in a low quantity. Here we have effects of impurities in water. If water is brackish, then brackish water for irrigation and farming. Sometimes the water may contain too much of common salt, thereby rendering it to brackish and making it undrinkable and less useful for cloth washing or for irrigation and farming. Water with bacteria, then sometimes the water may contain harmful bacteria, the presence of which may cause disease such as cholera, typhoid, dysentery, gastro, and infection such as hepatitis A. After all these, we have need for what that why we should treat the water or why we have a need of water treatment, because to ensure safety for public, economy, utilities, industries, and many other uses. Therefore, becomes imperative upon the planners and designers of the public water supply schemes to thoroughly check, analyze, and treat the raw available water for safe and permissible limits before supplying to the consumers or public. Here we have a full diagram of a water supply scheme that, for example, if any public health engineer or water supply designer, if he design any water supply scheme, he keeps these sort of things in his mind, that any water supply scheme is designed at least from 30 to 50 years of the life. So first of all, we select the source, then we install the pipe network, then water collects are stored in an intake. Here, this is MDD is equal 1.8 Q. We will read when we have a water calculation. We will, so now no need to discussion of these values and terms right here. Here we are concerned. We are only concerned with the water supply scheme. So after intake, there's the main pipeline, and here we have treatment units like 1, 2. One is MDD, MDD, 2Q. These are all known as water treatment units. For example, if this is the MDD, here we have first we have primary sediment tank, then we have secondary treatment tank, then we have filtration chamber, then we have disinfection units for removal of pathogenic or disease causing bacteria. Then we have softening for ionisant method and via zeolite method. Then after these filtration or treatment units, we have again we have pipeline network to convey it to the reservoir or tanks. Then we have pumps, and finally distribution system for supplying the water to the homes safely. For calculation for the design of distribution system, we have maximum of 2. So all these terms we will discuss in detail in all formula in our coming lectures. Now we have water demand. So I hope you enjoy the lecture we start this water demand because this is a complete chapter. So we will discuss in our lecture number 4. So thanks for watching and hope we will meet with another lecture number 4 for the course of environmental 1 and 2. Thanks for watching.